Alright, hey folks, welcome back. I just wanted to point out the end of this last video where we were trying to solve out this secondary part, which was the cubic after finding the 1 had worked. So keep in mind, of course, that we had an upper bound. If we plug in something like 1/5 and use that out in this particular problem, that gave us a 5, and then this became a 1 and a 0, and then this was 0, 11, 11/5, and a positive remainder. So this became an upper bound for us, which means this is plus, 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 and plus. So we have no more values to the right of that would work. And you could test this out on the negative side and find the same thing happens for, say, negative 4/5 or others, and we'll talk more about those as lower bounds later on. But I did want to go on to this next example, which is, let's see if we can get that on there. There it is. 4x cubed minus 11x squared minus 36x minus 20. So here's a good example of a problem that doesn't have a whole lot of stuff going for it. It's got a 20 in the numerator for our possibilities. It's got a 4 in the denominator. So 1, 2, or 4. 1, 2, excuse me, 1, 2, 4, 5, 10, or 20 in the numerator. That's going to give us a lot of possibilities again, and the fractions, etc. So one of the things we're going to do here is we're going to look at how we can isolate these things a little bit better for ourselves using the graphing calculator. This is a perfect example of that. This thing is a beast to do by itself, and I can tell you right off the bat, and I believe that negative 5/4 is the only thing that works. So I'm going to show you on the calculator what that looks like. I've punched this into the calculator, and if I draw it, I see that I've got these 3, it looks like maybe 3 values. So I'm going to click on my G-solve, and when I do that, I'd like root, and on the far left, I get negative 1.25, and that's the one that's the negative 4/5. And then if I go to the right, I get this, which is an ugly decimal. And that means that that one was irrational. And then I go to the last one, and I see that's also irrational. So I'm going to jump back over here, and I'm going to see that negative 1.25 is the number I'm looking for. So this is a perfect example of a problem on a test where I would say use the graphing calculator to assist you. And then negative 1.25 is the value we're going to try out. So that gives us a lot of help over here. That's negative 5/4. And we know it's going to work, so that's a 4, negative 11, negative 36, and negative 20. And we know this is going to work because the calculator told us so. So 4, this is going to be negative 5, negative 16. Cancel that, and we get positive 20. And that gives us a negative 16, and another positive 20. And then we've got our happy face over here. So we're going to do that little factor jumping again. This is x minus 5/4. And we're left with 4x squared minus 16x minus 16. And I'm going to jump a 4 from that quantity into the other one. So that's going to be 4x minus 5, and then x squared minus 4x minus 4. And this will tell us now, right here, will tell us what those irrational values were. And just for fun, I'll finish this one out. So we've got 4x minus 5 equals 0, or x equals I'm sorry, I made a mistake here. Let me just jump back here. This is supposed to be a plus. My apologies here. Plus here. Going a little too fast. And that gives negative 5/4, or that negative 1.25. And then the other part using the quadratic formula, 4 plus or minus square root of 4 squared minus 4 times negative 4. This is a lot of 4's here, over 2a. All right, so that's what we end up with there. So 32 inside. We can hop out a 4 or the 16, so it looks like we've got 4 plus or minus 4 root 2 all over 2. Final answer here, 2 plus or minus 2 radical 2. And those are the two decimals that you saw on the graph. So that's a way for us to handle that very difficult cubic. And then what I'm going to do is stop here, and when we come back next week, we'll take a look at this type where it's known that radical 2 is a root, and we'll work through this 5th degree polynomial from there. All right, hopefully that'll get you started on this using synthetic division.